So, hi everybody. Here's a second part to this week's module. So, yesterday in class I did exponents and I said if you want I'll make a second one. So, this is the second video and I will do like I did in the other Tech Live. I will flip back and forth between the slides and MyOpenMath so I can show you how to put things in. Great. So, let's talk about like what are we doing and why. So what we're doing is we're continuing to try to solve problems, right? That's where we want to end up. And so I put something like that we've done before is like, think we wanted to solve x squared equals 4. Well, if I had x squared equals 4, I would take the square root of each side, right? And that would tell me x is 2. And actually we would say plus or minus 2. But if I get bigger and I say like x cubed is 125, well, same thing. I think, well, let's take the cube root of x cubed. And we would take the cube root of 125, and we would get x is equal to 5. But now that we've changed to exponential problems, where the base is constant and the exponent is what's changing, things get a little harder because when I look at like the fourth root of x, I can't really take the xth root. I'm like, I don't know what x is, so how am I going to take that root? So that's why we need this new thing called logarithms, is to figure out like, how will we get to that next part? So let's start with our definition. So this is just what we call it. It's called a logarithm, and we write it the log base b of y equals x, where b is greater than 0, b is not equal to 1, and y is greater than 0. It means that b to the x equals y. What I think about is log says what power of the base gives you this value of y. So I kind of like this idea of when you see log to think about power, right? That's really what it's saying. So if I take that problem I just showed you, 4 to the x is 4096, I would write it as the log base 4 of 4096, and then that's equal to 6, because 4 to the 6 is 4096. So we're going to do a lot of these. Like, don't worry, we're going to do a lot of these, but I really do have this idea of when I say log, I want you to think about power. And there's another video you could go watch in the learning resources that talks about like just an introduction. So if things are harder, like, and if you need more, remember, go to the learning resources. It will show you more. This video is just intended to like, let's try some of all of the homework. So this is how we start. And remember, think power. So when I see the log base 5 of 25, the answer is going to be 2. What I'm thinking is 5 squared is 25. So I was thinking, what power of 5 gives me 25? And it's power 2. So I keep saying this word power because I don't want you to think multiple. You think power. So then I think, what power of 2 gives me 8? That would be 3. 2 cubed is 8. You could also try just rewriting, like this log base 9 of 1 over 9 is like 9 to the negative 1. So here, log base 9 of 9 to the negative 1 is negative 1. I could do that here. Log base 2 of 8, 8 is 2 cubed, it's 3. You kind of want these two numbers to match, and then you grab the exponent. So this one says the log base 2 of 32. So maybe you want to rewrite it. And you could use your calculator and do powers of 2, but it would be 2 to the 5th. So I'm only taking that power, that's 5. Log base 6 of 6, 6 is just 6 to the 1, so log base 6 of 6 is 1. This log base 4 of 4 to the 15th is 15. So there's a couple things that might help to know. The log base b of b is 1. That's just a rule. The log base b of b to the x is x. So if it's helpful to have these rules, you can write them down and use them. Your calculator has logs, so I wanted to put up just a generic picture of a calculator in case you use a handheld. Let me point to it right here. It says log. Notice it doesn't say a base. So anytime there's no base, then it's called the common log, and that log would be 10. Think we're kind of a base 10 kind of a number system anyway, so it's just doing what's normal for us. So when you just see log, no base, it's understood to be 10. Kind of like the square root where you don't write the index of 2. So it's kind of nice that you have something that's in the calculator and then you don't have to do powers, but you could if you wanted to. This is saying log base 10. This would be 3. See how it's 1, 2, 3 zeros? But if I get to the log of 497, I don't know what that is. So I hit in my calculator, I push the log, I hit 497, and it says it's 2.696. Let's do 4 decimal places. So I have 3.5. I'm going to call it 4. But no way to do this. Like, you got to use your calculator. All right. The other one that's really essential to understand is natural log. Natural log is log base e. So when you see ln, it means it's a base e. Again, you have to have your calculator to do this. This one, natural log of e to this 6.3, you can hit in your calculator, you're going to get 6.3. There's rules like natural log of e is 1, and natural log of e to the x is x. So because natural log is log base e and I have e, they cancel each other out. And then if I have like the natural log of 73, I hit ln, I hit 73, I'm going to do 4 decimal places. I have 4.290, I'm going to call it 5. And then I just picked a bigger one, natural log of 8,265, and this is 9.01. Let me show you what I have. I have 978, so 1, 2, 3, 4. 9.0198 if I do 4 decimal places. Again, I'll go to the calculator really soon. This one says I have the log base 3 of 55. It depends on your calculator. Some calculators can do a change of base and some of them don't. It really just depends on what you have. So I'll show you how to do it with a change of base and without a change of base. If your calculator does not have something that says like what you would look for is like log base b of a kind of thing. If you have a button like that, awesome. If you don't, then we do change of base, which says you could either use natural log or you could use log. You'll get the same thing, and I'll show you when we go over to, like, I'll go over to Desmos, and let's go ahead and do that. So I'm going to start with the natural log of 55, and then I'm going to hit divide by, and then I'm going to do the natural log of 3. So here's the number. I can also do the common log of 55 and then divide by the common log of 3, and you see we get the same number. Luckily, Desmos is pretty smart, so I could have just said the log. I'm going to do the underscore, which pushes it down, and then my base was 3, and then I hit my arrow over, and I do 55, and I get the same thing. It should also be that if we open up the keyboard, so opening up the keyboard, you just go down till you find it. So here's log base A. So that brings it up with the place to put in the base, and then you go over and you put 55, and you can see they're all the same. So you have choices. I like choices. We'll do that one more time. I just like to show you more than once. So the other one I was going to do log base 4 of 811. So I could do log underscore 4 of 811. I can do natural log of 811 divided by natural log of 4. I can do regular common log of 811 divided by common log of 4. So you're just consistent, right? Whatever you're going to do, you just do the same over and over, but you need technology to figure these out. Logs get pretty small pretty quickly. Look at 811 is only 4. But the idea is, if I take this number 4, the base, and I raise it to this power 4.83177905211, see how I get 811? So it's coming backwards around, right? So always between the two, they should be equal. Right. So some of the questions will say write back and forth, and what we're trying to do here is just get really familiar with how these two things are related to each other. Our rule is the log base b of y equals x means b to the x equals y. I tend to write these arrows, b to the x equals y. So if I want to just rewrite this, I'm not solving, there's nothing to solve for, I just want to write this over. So this is 4 to the 5th power is 1024. So I say 4 to the 5th power is 1024. Same thing here. The base 3 to the power negative 6. So 3 to the negative 6 is 1 over 729. Nothing to solve for. Even if the problem gave you an x, let's say I had the log base 3 of x is equal to y. I don't want to solve. I just want to rewrite 3 to the y is x. We just want to get used to this new notation. So opposite, I also want to be able to write from an exponent, make it a log. I think the most important thing to think about here is the base, right? So the base is 2. So when I go to write this, I'm thinking my base is 2, right? So this 2. The answer is the exponent. So the answer is the 6, and I'm taking the log of 64. So I kind of try to separate it into, can I see what the base is? Can I see what the power is? Okay, what would I take the log of? So 5 to the negative 3 is 1 over 125. The base is 5, so I write the base. The exponent, negative 3, goes on the right, and 1 over 125 in the middle. To talk about graphs of logs, I thought we would start with a graph of an exponent. And I want you to know they're inverses, so they're exact opposites. So inverses say, if xy is on f of x, then yx is on f inverse. And that's exactly what a log is meant to do. It's meant to flip whatever exponent you have. So I'm going to flip all of these. So let me write a few down for you. 0, 1, I'm going to make it 1, 0. 1, 2 is going to become 2, 1. 2, 4 is going to become 4, 2. Negative 1, 1 half, I'm going to make it 1 half, negative 1. So those are just points that are on this graph, and I'm just going to put them in. So this 0, 1 became 1, 0. This 1, 2 becomes 2, 1. Then I have 4, 2. I said if I have a half, it's negative 1. If I go to a fourth, it's negative 2. An eighth would be negative 3. So you have this graph that looks like this. So all I did was flip it. Hopefully you notice it kind of looks like it's running along this line, and let me make it a different color. So we have an asymptote here at x equals 0. So you're not going to take the log of negative numbers. Remember we said earlier that you only take the log of a positive. So this asymptote is keeping us from using any negative numbers. So log base b of x has a vertical asymptote at x equals 0. The points you're going to use are 1, 0, and b1. So remember, with exponents, we use 0, 1, and 1b. We just flip them around, make them 1, 0, and b1. Domain, positive, so 0 to infinity. Range is everything. Transformations will come in just like they came in when we did exponents, so that'll change it up a little, but this is where we start. So we're going to start really small. I have the log base 3 of x. Let's give a color. So the points I said we're going to use are 1, 0, and b1. So for us, that's 1, 0, and 3, 1. That's the only things you need. So 1, 0, 3, 1. It tells me how it curves, and it goes along this x equals 0 line. So just 2 points, and I'll head to MyOpenMath really soon to show you. So let's think of this. When I look at doing these logs, and we're going to have these vertical asymptotes, you only take the log of a positive. So if you get questions about domain, you look at what you're given, like 10 plus 2x, and you set it greater than 0, not greater than or equal to, just greater than. So this says 2x is greater than negative 10, x is greater than negative 5. That's open, negative 5 to infinity. Same thing, log base 7, 9 minus x, I say 9 minus x is greater than 0. Negative x is greater than negative 9. Remember, when I divide by negative 1, I flip it to x is less than 9. So this is negative infinity to 9. It doesn't matter at all what base you're talking about. So if you look at this, This was base 4, this is base 7. I don't use that at all. You just grab whatever you're taking a log of, set it greater than 0. So when you go to graph these, in MyOpenMath, you have to include the vertical asymptote, and I'll show you how to do that. But I probably would start by writing on your paper like what it's going to be. So like this one, the vertical asymptote is at x equals 1. So you take the part you're taking the log of, set it equal to 0. That's where your vertical asymptote is going to be. This says it's shifting 2 right. So 2 to the right. Remember how we think like x minus 1 equals 0, so that tells you the area. And then 2 up. So we're going to go 2 right and 2 up. Let me show you one more before we go over to MyOpenMath. This one, x plus 1, so I say x plus 1 equals 0. X equals negative 1 is my vertical asymptote. That says it's going 1 left. And the plus 1 is up 1. So that should help you, like how to graph is just look at your transformation. So let's go over and share. Because I'm going to do those two in MyOpenMath.
I want to show you how to use the graphing tool inside of MyOpenMath this week. So first thing you're going to notice is that there's a line, there's a curve with a dotted line, and there's a dotted line with a curve. So when you are graphing, you're going to graph the asymptote along with the logarithm. This is log base 2 of x minus 2 minus 4. Logs have vertical asymptotes, so you want to click this tool with the vertical asymptote, and you're going to start by putting a dot where the vertical asymptote is. X minus 2 is 0 when x is 2, so after I click this dotted line with a curve, I go to 2, anywhere on 2, and I click it. Now it's ready to graph the log. What I think about is usually logs start at the point 1, 0. This minus 2 is going to move this point 2 to the right. Then the minus 4 is going to move my point 1, 2, 3, 4 down. The second point I usually go to is the base. So this base 2 would mean I was at 2 and then at the number 1. But this time instead of 2, 1, I go from 2, 1 over 2, and then I go down 1, 2, 3, 4. So here's my point. Let's hit submit so we can see that we got it right. Let's hit similar question and do it again. This one says log base 4 of x minus 3 plus 4. So I start by thinking about x minus 3 is 0 when x is 3. I pick my tool, I go to the number 3, I put a point. Then I think about I always start at the point 1, 0, but I move 1, 2, 3 to the right, and then I go up this time 1, 2, 3, 4. My next point, my base is 4, so I go to 4 and then up to 1. I move 1, 2, 3 to the right, and then 1, 2, 3, 4 up. So I want you to think about we used to use the point 1, 0, and then the base at 1. Then you do your transformations, horizontal, vertical, just like we have when we graphed other functions like parabolas or the square root. Now we just have this curve for a logarithm. 11 and 12 are both the same in the homework, so you're going to see the same kind of thing where you have the tool, use the tool, like let's try this one. This one says x plus 3, so I go to negative 3 and I put my vertical asymptote. When you look at the vertical asymptote, doesn't matter what the base is, you just look at what's in parentheses. After I do that, I think about the point 1, 0. X plus 3 says move 1, 2, 3 to the left, and then I go plus 4 up 1, 2, 3, 4. My other point is usually the base. My base is 3, and I go to 1, but now I move 1, 2, 3 to the left, and 1, 2, 3, 4 up. You can see the curve keeps switching as you pick the points, so don't worry about if it doesn't look right to begin with. Worry about what it looks like when you're finished, and of course you hit submit to see how it is. If you forget, I have videos embedded, so you can go to the video. It will remind you how to use the tool.
So there are 3 rules for logarithms, and what I did is I wrote them down with the rules of exponents so you could see where they were coming from. So the rules for exponents says when I multiply, I add. When I divide, I subtract. And when I raise to a power, I multiply. The rules for log say when I multiply, I add. When I divide, I subtract. And when I raise to a power, I multiply. So these work both directions. So this works as expanding to take 1 log, m times n, and expand it to log base b of m plus log base b of n. It works to divide, you subtract. It works to take the power and bring it out front. They're all very important. This week we learn it, next week we use it, is what I say. I feel like this one I use the most. So we need these to be able to solve next week. So I'm just going to practice that. I left the rules here so you can see them. And then we're just expanding. So expanding means instead of having the multiplication, let's write it as addition. So as you expand it, you need to write the base. So log base 5 of 3 plus log base 5 of x. So make sure you include the base when you do this. Same thing, when I divide, I want to subtract. So I have to write the base, log base 7 of x minus log base 7 of 5. So it's top minus bottom. And I thought, let's do just a couple more. This one is a power. So the power comes out front. So this is 4 log base 6 of x. I'm going to rewrite this one before we start. So this is log, x plus 3 is on the bottom. This is x to the 1/2 on top. So I want to see that power. That'll be helpful. So first I see division. So I'm going to write this as the log, x to the 1/2 minus log. I'm going to put it in parentheses, x plus 3. But I can do one more step. This power can come in front. So 1/2 log of x minus log of x plus 3. If you are headed towards calculus, you do use these rules a lot when you get to calculus. We want to be able to expand logs. It makes things so much simpler. So if you know that's where you're headed, this expanding logs is really important to you. When we go to solve, it's really important that we can put them together. It depends on what we're doing to what we decide to say. What I think about is anything negative goes in the denominator, anything positive goes in the numerator. So as a single log, I only have log base 4. I have division because I see a subtraction. So this x is positive, it goes in the numerator. This is negative y goes in the bottom. 3 is positive, it goes on top. Just because we like the way it looks better, I'm going to write this the log base 4 of 3x over y. This next one says natural log of 5 plus natural log of x squared plus 1 plus natural log of 6. So all positives is I don't need a fraction. But I have 5, I have x squared plus 1, I have 6. I'd probably write that 5 times 6 is 30. This is x squared plus 1. I wouldn't multiply that part out. Usually we think we like things in factor form. That should get you through the homework. So if you have questions, as always, reach out, but this should help with Week 5, number 2, homework.